An element's properties depend on the structure of its atoms. For example, if the atom has a proton of 8, then it's called an oxygen, and if it has a proton of 6, then it's called a carbon. An atom is composed of 3 things. In the middle is called the nucleus, which has proton and neutron. Protons are positive and neutrons have no charge. And then on the outside is called electrons. In science, we write elements in this format with 2 numbers, one on top and one on the bottom, and then a short letter symbol for whatever the element we represent. In this case, Na is sodium. And the number 11 represents the number of proton found in sodium. It's also the atomic number. The number on top, 23, that represents the atomic mass, which is how heavy the sodium weighs. The number 11 represents both proton and electron. So in sodium, there's 11 electrons and 11 protons. Now, in order to find the number of neutron, we simply take the atomic mass, which is how much the element weighs. We subtract it from the number of protons, so that's 23 minus 11, and we get 12 neutrons. Sometimes elements have the same number of proton, but different number of neutron. For example, in this case, carbon has 12 neutron, and the other carbon has 14 neutron. Elements like these, we call them isotopes. Now, isotopes are really useful. So what if we have the same number of neutron, but instead we have different number of proton this time? Because if we have the same number of proton, but different neutron, we call it isotope. What if they have different number of protons? Well, we see here we have the same number of neutron, the numbers on top, but we have different number of proton. Then that's just called a different element. In this case, 6 is carbon and 7 is nitrogen. It only works for a neutron if they're different, then it's isotope. Otherwise, if it's different proton, then we just call it a different element. So isotope is useful because some of them are radioactive. For example, C12 is stable. It has 12 is the atomic mass. If we take that, we subtract it from 6, the proton number on the bottom. So that gives us 6 neutrons. So we have 6 neutron and 6 protons, so C12 is stable, whereas C14 is unstable. It has only 6 proton, that's the number on the bottom, and the number on top, 14 minus 6, that gives us 8 neutron. So 6 and 8 is not stable, so it becomes a radioactive isotope. So what happened is this element, C14, it gives off radiation. Now in science and medicine, we use this to put it through organism, and then wherever that isotope goes, it gives off radiation, and we can use a PET scan. It's one of those machines you see in the movies all the time where people just lay on and they get put through this white chamber, and then they turn on all of the light, and then all the cool stuff happens, and then you get this really cool scan, which is a PET scan, and it scans for all the radiation give off by the isotope that you put into the organism, in this case the human body, and you can use that to detect, for example, like cancers or any other kind of disease that we're looking for specifically. So, element, atom, in the middle is nucleus, outside is electron, the nucleus has proton and neutron, number on top represents atomic mass, number on bottom represents the proton and electron. You take those 2 numbers, subtract them from each other, you get the number of neutron. If you have the same proton but different neutron, it's called isotopes. Those things are used in science to help doctor figure out what's wrong with the person.